So, how's everybody feeling? I mean, the 3-day next week can't get here soon enough, right? Ay caramba. Parent-teacher conferences. Yeah. So, that's not bad, right? All right. So the plan for today, oops, gosh darn it, this, I'm having such a hard time with my windows. We'll start with some questions. I think last time I'd given you guys 2 worksheets to work on, worksheets 1 and 2, right? Bless you, all of you. Do we have questions from either of those worksheets 1 and or 2 that we'd like to talk about? Nicole.
Number 8 on worksheet 1.
Worksheet 1, number 8. Sure. All right. So it's a little bit tricky here in that we have a secant, but it's okay. So suppose let's start by, I'm going to translate this secant problem into sine, cosine, or tangent problem. It'll be easier to look for things on the unit circle with that doing so. So remember that secant is equal to 1 over cosine, right? And I'd prefer for this to be just cosine instead of 1 over cosine, right? So what I'm going to do is I'm just going to flip both sides. So I'll think about square root of 2 is square root of 2 over 1. So when we flip both sides, we're going to have that. And, well, let's rationalize our denominators, because on my unit circle, I know I don't have any square roots in the denominator. So what I'm going to be doing is I'm going to be searching for the places that x is equal to root 2 over 2. I'm sorry, negative root 2 over 2. So if I look at that on my unit circle, that's going to be 3 pi over 4 and 5 pi over 4. If you look at your unit circle along with me, you'll see that those are the 2 same places. Now if I check, now my answer has to be between pi and 2 pi. Well, 3/4 of a pi ain't gonna do it, right? 3/4 is not between 1 and 2. But 5/4, or 1.25, is. So that's my answer. Does that feel okay, Nicole? So whenever I get any of those reciprocal guys, that's probably the route that I would take with it. Is just like, okay, I'm going to turn it into the regular version, and in doing so, I have to flip both sides. Troy. Worksheet 2, number 2. So here we're wanting to find cosine inverse of 0.56 with an answer between 2 pi and 3 pi. So I'm going to start by drawing my picture. That's the way we always start one of these. I notice that my answer needs to be between 2 pi and 3 pi, which tells me my answer is positive. So when I start counting on my units, or on my XY axis, I'm going to be going counterclockwise because I'll have a positive angle. So I'm just going to count each quadrant by, which is pi over 2. So I 0, pi over 2, pi, 3 pi over 2, up to 2 pi, and then 5 pi over 2, and then to 3 pi. Notice as I'm going around, I'm crossing out the old one and replacing the new one. So my answer that's between 2 pi, or the section of my XY axis that's between 2 pi and 3 pi is quadrants 1 and 2, right? So far, so good? The next piece is, I notice here that since the 0.56 is positive, we're interested in where cosine is positive. Well, if I remember all silly turtles crawl, cosine is positive in A, where all of them are positive, and C, where cosine is positive, so that's quadrants 1 and 4. So my answer should be somewhere in quadrant 1. So there's my angle theta. Troy, you happy so far with what I've done? Okay. Now we'll draw in our alpha. So alpha is always made between the terminal side and the x-axis. So there's my alpha. So I remember that alpha is always going to be equal to inverse of the absolute value, and then whatever the value is. Now, in this case, does it really matter the absolute value? No, but I'm always going to write it because the last thing I want to do is be willy-nilly about it and forget to do it when I really need to. All right, the last thing I need now is to write my equation for theta. So the last part of the x-axis, or the part of the x-axis that makes up my alpha, is 2 pi. So that's going to be where we'll start. And then because when drawing my angle theta, the last axis I cross before getting to the terminal side is the x-axis. That tells me plus, and then whatever alpha is. So now it's calculator time. So I'll go fire up my calculator. As a reminder, what mode does my calculator need to be in to do this kind of a problem? Needs to be in radian mode, so if you get a goofy, crazy looking answer, it's likely that that's the issue. Now, all the classes I do are all radian classes, so I don't ever switch it back and forth, but I'll check real quick anyways. It is in radian mode. So I just do 2 plus cosine inverse of 0.56. Notice that I did the absolute value in my head here rather than putting it into my calculator. I'm never going to type the absolute value symbols in my calculator because it's so easy to do it in my head. But you need to remember to do it. So my answer should be 7.26. And I should check that because every one of these answers is checkable, and the check is pretty easy. So I want to make sure that if I do cosine of my answer, I get 0.56, which I do. Fantastic. And I need to make sure that 7.26 is bigger than 2 pi. Well, what is 2 pi? Well, 7.26 is bigger than that. And it's got to be less than 3 pi. So what is 3 pi? Okay, it is less than that. I am 100% convinced I have the correct answer, as it satisfies my equation at the beginning, and it falls within the desired interval. Does that feel okay? Cool. Others with questions from homeworks? Or just questions in general? Okay. Today we're going to finish up section 4.1. So we have a couple of ideas still kind of like straggling here, hanging on in 4.1. It won't take too long. Though I would say that this week you might want to be ready for a homework quiz. I would make sure that I'm good to go on worksheets 1 and 2. If I am able to do that, I would feel real good about my homework quiz prospects. Everybody cool? Okay. So I want to do a couple of last little hanging pieces here in 4.1. So if you see the prefix arc attached to sine, cosine, tangent, cosecant, secant, cotangent, means the same thing as inverse. So if I write arc sine of 0.5, that is the same thing as sine inverse of 0.5. It's just like a different notation. You'll probably see that in the homeworks at some point. Everybody's okay with that? It's just another notation. They are used interchangeably depending on the, the origin of the materials written. Some people like inverses, some people like arcs, some people do both. You'll see both. No big deal. Doesn't mean anything different. So what if we have so the next thing I want to talk about is how we deal with a example where we have like a composition, so like a function inside of a function, where one of the functions is a regular trig function, the other is like an inverse. So let's say we have like cosine of sine inverse of 0.5. When we're doing these kinds of problems, we're always going to work from the inside out. So the first thing I want to deal with is the sine inverse of 0.5. Now notice that we didn't give you any interval over where to find sine inverse of 0.5 like we did in the other worksheets. If an interval is not given to you, we have to go back and use the fundamental range for sine inverse or cosine inverse or tangent inverse from the previous lesson. So in this case, my answers are going to come between negative pi over 2 and positive pi over 2. Is everybody okay with that? So if it doesn't tell you where your answer needs to be, it's coming from those fundamental ranges. All right. So remember that pi over 2 to, negative pi over 2 to positive pi over 2 is covering quadrants 4 and 1. If I do like an all silly turtles crawl, well, sine is positive in quadrants 1 and 2. So I know my answer I'm looking for is in quadrant 1. Everybody agree? So, do you recognize 0.5 as a unit circle value? It's the same as 1/2. So I'm going to go to my unit circle. I'm going to look in quadrant 1 for where sine, or the y coordinate, is 1/2. What value or what angle measure in radians is the y coordinate equal to 1/2? Pi over 6. So what we have then is cosine of pi over 6. Everybody's okay there? We dealt with the inner piece. And then, hey, I know how to do cosine of pi over 6. I'm going to locate pi over 6 on my unit circle. And since it's cosine, I'm going to look at the x coordinate, which is root 3 over 2. And that should be my final answer. Okay. On these kind of problems, I'm always going to give you like unit circle values to use. So it's just about like making sure we understand how to use our unit circle. Let's do one that's the other way around. So here we're going to do sine inverse of tangent of negative 3 pi over 4. So the first thing I want to do is work on the inside portion. So I would, since I'm doing just a regular trig function, I just need to look up where negative 3 pi over 4 is on my unit circle and then do tangent of that. But does my unit circle go to negative 3 pi over 4? Rats. What do I do if it doesn't show up on the unit circle, but I'm pretty sure it's supposed to be using the unit circle? I need to find an angle that's coterminal to the negative 3 pi over 4. How do I do that? I add 2 pi. So to add negative 3 pi over 4 and 2 pi, what do I need to have? Great. What would that common denominator be? 4. So that's negative 3 pi over 4 plus 8 pi over 4. And to add fractions, how do I do that now that I've made a common denominator? I add the tops. What do I get when I add the tops? 5 pi. And then what happens with the bottom? Stays the same. So what I really want is 5 pi over 4. That is a unit circle value, right? So on the unit circle, I'm going to find 5 pi over 4. I remember tangent is y over x. The y coordinate is negative root 2 over 2. The x coordinate is negative root 2 over 2. So what do I get when I divide negative root 2 over 2 by negative root 2 over 2? Just 1. So what we have now is just sine inverse of 1. So again, we're not told a specific value to look for. So I need to be looking between negative pi over 2 and positive pi over 2. Do you guys remember where that was on the unit circle? We just did it in the first problem, right? Quadrant 1 and 4. But since it's a positive value, we know we're looking in quadrant 1. So if you look in quadrant 1 on the unit circle, where y is equal to 1, what value do we come up with? Pi over 2. And that is our answer. What do you guys think so far? No big deal, right? It's just like 2 unit circle problems kind of combined into one problem. But it's just really about being comfortable using that unit circle going forward or backward. Let me give you the classic, I'm going to trick my students question. So here we have arctan of tangent of 2 pi over 3. Who thinks the answer is just going to be 2 pi over 3? Shouldn't tangent inverse or arctan just cancel tangent and leave us with 2 pi over 3? You'd want it to work that way, right? Unfortunately, that's not the correct answer. The reason is the fundamental range for tangent is negative pi over 2 to positive pi over 2. And 2 pi over 3 is not in there. This is the classic, your math teacher is going to give you this tricky problem or something equivalent to it to make sure you understand to use that. You have to be using that fundamental range, and we can't just cancel those things all willy-nilly. Does everybody feel okay as to why that answer is not going to work out? All right. So let's do this the way that we had done previously. There is not a shortcut, unfortunately. So I'm going to go into my unit circle, locate 2 pi over 3. And I know that tangent is y over x. The y coordinate at 2 pi over 3 is square root 3 over 2. And the x coordinate there is negative 1/2. So that becomes negative root 3. So we have now is arctan of negative root 3. So if I go and think about, okay, arctan is covering quadrants 1 and 4, just like before. And then arctan is negative in quadrants 2 and 4. So the answer I want is in quadrant 4. So I'm going to go and look for the place where my y coordinate is negative root 3 over 2, and my x coordinate is positive 1/2. Now I know the negative goes with the y because what quadrant am I in for my answer? Quadrant 4. Is the y coordinate positive or negative in quadrant 4? In quadrant 4, the y is negative, but the x is positive. So I knew where to put the signs on that. Now I know that it's going to be the same x and y as it was the first time, but the signs could be in different places, which is what we're seeing there. But taking a minute figuring out what quadrant my answer has to be in tells me where to put the signs. Did you guys see that? So if I look at my unit circle for the place where the x is positive 1/2 and the y is negative root 3 over 2, I get 5 pi over 3. But that's not in our interval. So what do we have to do? Yeah, we'll just find something coterminal to it. So we have 5 pi over 3 minus 6 pi over 3. I'm going to make the common denominator there. We talked through it once. I'm not going to do it in like excruciating detail a second time. Is everybody okay with that? Okay. So that gives me negative pi over 3. That's the one I want. So I just wanted to make sure we did one like this that reinforces that you still do the same thing, even though it looks like, oh, I really want to just cancel those things out and just say, oh, that's the answer. It's so fast. Sometimes it's that easy. Most of the time it's not. If it makes it onto Mr. Kulik's test, you can probably count on it not being the easy way or the easy situation. Is everybody okay? All right. There's one more type of problem that I want to talk about. Oh my goodness. Okay. New example here. What if we have an inverse trig function with basically no numbers? So for example, let's say we have arc cosine of 2x. Well, let me start this way. So find an algebraic expression for We'll do a couple of examples maybe. Arc cosine 2x. So what I'm going to do is I'm going to start by rewriting 2x so that it's a fraction. So I'm just going to say, okay, well, that's just going to be 2x over 1. Everybody's okay there? Now, arc cosine is giving me an angle theta, right? That's what we're getting from it. So that's equivalent to me saying that cosine of theta should equal 2x over 1, right? So if I have a right triangle with acute angle theta, then the opposite side should be 2x, and the hypotenuse should be 1. Oh my goodness, guys. Everybody's okay here? I made a little oopsie daisy here with this. This should have like a sign on top of it. My apologies. Okay, so we have, oh my gosh, Mr. Kulik, cosine is not opposite over hypotenuse, is it? What is cosine? Adjacent over hypotenuse. Good golly. At least we got that straightened out before we started drawing anything in our triangle yet. So I know this side is 2x. That side is 1. And then how am I going to find that other side? I'm just going to call it y for right now. And I'm going to use the Pythagorean theorem. So I can say 2x squared plus y squared is equal to 1 squared. So y squared is equal to 1 squared minus 2x squared, or y is equal to plus or minus the square root of 1 squared minus 2x squared. And now I'm going to drop the minus from the plus or minus and simplify the 2x squared. Why am I able to drop the minus from the plus or minus? Why didn't I drop the plus and make it a minus? It's okay that I did it. What is y representing? It's a side length of a right triangle, correct? Can the side length of a right triangle be a negative number? No. That's why we're able to drop the plus or minus and just go with the plus. That feel okay so far? So now that I've constructed my triangle, arc cosine of 2x just gives me some angle theta, right? So if I do sine of theta, That's going to be opposite over hypotenuse. If I go to my triangle, the opposite side is that square root 1 minus 4x squared. And the hypotenuse is 1. Or if I just simplify that down, I have square root 1 minus 4x squared. Let's do another one like that, though. What do you guys say? It's a little bit trickier. Because you have everything as an expression. So let's say we have, double check here before I get going too far. Who's like so over this stupid fan buzzing like this? Does anyone have an extra sledgehammer I can use to fix that? No? Ugh, be a lot cooler if you did. Okay, so here we have cotangent of sine inverse 2 minus x. So I'm going to start by looking at the inside. That's going to give me my theta. So I'll draw my right triangle. If I think of 2x or 2 minus x over 1, and I have sine, which is opposite over hypotenuse, the opposite side should be the 2 minus x. The hypotenuse should be 1, and then I need to use the Pythagorean theorem to find this third side I'll call y. Everybody cool? So y squared plus 2 minus x squared equals 1 squared. So I'm going to subtract the 2 minus x squared to both sides. We'll square root both sides. In doing so, I'm going to drop the plus or minus and just go with the plus. Why can I drop the minus? It's a side length to a triangle. It has to be a positive value. And then we'll simplify this out. How do I simplify 2 minus x squared like that? How do I simplify that? Okay, well, if I ask you, what is 3 squared equal? What would you tell me? 9. How'd you get 9? But how do you square 3? 3 times 3. So 2 minus x squared must be 2 minus x times 2 minus x. And how do I multiply something like that out? You FOIL. Everybody's okay there? So if I FOIL that out, I get that. Now I combine my like terms and stuff incorrectly, you dope. Let's try, it should be minus 4x in the middle. But I did that in my head. If you can't do that in your head, you take the additional steps if you need to, no big deal. All right, so who thinks that this is then what we'd have? Does that look good to you guys? Mr. Kulik, it looks good to me, but the way you're asking this question makes me suspicious that there's something wrong with what you've written here. You're correct. I've made an intentional mistake because I would guess that 8 out of 10 of us at least will make the same mistake again and again and again. So I'm showing you here and making a big deal out of it in the hope that I pick up a couple of other people that'll catch this mistake and not do it. So here is the mistake, is that minus sign needs to apply to the entire thing we just FOILed out. So that negative then needs to distribute through. I know, guys. But I'm showing you all the good tricks now, so hopefully when it comes later that you'll catch them. And I can combine 1 minus 4, right? So that's what I need. Everybody feels good? Okay, but we're not done, right? Because we still have to do cotangent of theta. And remember, cotangent is adjacent over opposite, right? So that's going to be -3 plus 4x minus x squared, all square rooted, over 2 minus x. Then we're done. So again, the way to think about this, I use the inner piece to draw a right triangle. Once I have that right triangle drawn, I then use the outer piece on that right triangle that I've drawn. But you got to get it all labeled before you're done, right? So you got to find that third side of your right triangle. But they're kind of all the same. The algebra can get a little messy there, but it's basically we're just doing SOHCAHTOA once you've got your triangle. And even to make your triangle, really, we're just doing SOHCAHTOA. What do you guys think? This feels like a good place to stop. You guys should be able to do for homeworks. Let's see, let's do 11 to 14 and then 17 to 18. And if you haven't finished your worksheets 1 and 2, which seemed like probably many of us were in that boat, you could even start work there before you moved on to this stuff. Or you can be like, yo, Mr. Kulik, we just did this stuff. I'm fresh on this. I'm going to do that now and come back to those worksheets later. That's okay too. Or if you're behind on your delta math, shame on you, you could get going on that if you hadn't finished that yet. But this is where I'm going to sign off and let you guys take the remaining, 40 minutes or so of class, 30, 40 minutes of class to work on your homeworks, whether that be delta maths or worksheets or this new set of, it's like 8 whole problems, something like that. Nope, less than that. 6 whole problems. Ay, my goodness, Mr. Kulik, you're a slave driver. I think you'll be okay. This will be part of Sunday's problem set along with worksheets 1 and 2. What else should you expect this week? Homework quiz. What will that homework quiz be focused on? Worksheets 1 and 2. Would you get a unit circle to do the homework quiz? Of course you would. You would not have to memorize that. Sound good? Everybody Well, satisfied, let's say that. Maybe not happy. I mean, like Mr. Cool, like I'm never happy. I'm in math class. It's like you could be in worse places, you know? You have all of human history to choose from. Where would be the worst place to be? It's a hard question. My answer, a Roman soldier during the Battle of Cannae. The Carthaginians do like a double envelopment, so their whole army surrounds yours, so there's no escape, and you just have to wait for like hours as they slaughter into the middle. Sounds pretty stinking awful. They found soldiers in the middle had like smothered themselves, like buried their heads in the sand to try to kill themselves rather than waiting to be slaughtered. Sounds so pretty awful, the waiting being the worst part. To just know that like just waiting to be run through by a Carthaginian soldier. Yeah. Lousy day. Don't worry, the Romans end up winning the Punic War. But not a good day to be a Roman. That's my choice. Sounds pretty awful. Ranks right up there with like being in Pompeii during the volcanic, where you're slowly being covered with hot ash and suffocated with like noxious gases. But you had some warning, so it's good, you know, like that's your fault for not getting lost when you saw the volcano rumbling and tumbling for the past, you know, couple weeks and going, everything will be okay. Lots of people evacuated. That'd be a bad day though, too. Josh? Sure.